Last section, we're going to look at vectors. Vectors. Vectors are things that have size, magnitude, and direction. Magnitude and direction. And vectors are used in a variety of places along the way. One of them, an airplane, for example. And you decide you're going to fly an airplane, you're going to have to go to ground school and work with vectors. Because a plane's path is its direction, and its speed is its magnitude. And so we have magnitude and direction. Difference between a line and a line segment and a vector is that a vector, all of them are determined by 2 points. But with a vector, your 2 points deal with starting point, initial point, and terminal point. And it's a direction. This book uses lowercase bold letters for vectors. So vector V equals point P to point Q. Initial point, terminal point. Starting point, ending point. So here's a vector, PQ. It starts at P, ends at Q. That's the vector. But you'll notice that all of these vectors are the same size, parallel to each other, point the same direction. And so these vectors are what we would say are equal. Vectors are equal. Now, geometrically, one of the things that we can do is add vectors, subtract vectors, do arithmetic with vectors. Easiest way geometrically is to put your 2 vectors at the same initial point and then draw a parallelogram. And so vector V plus W, vector W plus V, is this vector right here. The diagonal from the starting point to the ending point. The other diagonal is the subtraction vector. And whichever way it points, the vector it points to is V minus W. If we went this direction, from V to W, it'd be W minus V. Opposite direction, same size. So vectors. Right? Now in vector work, we're only going to be talking about vectors, okay, magnitude and direction, and things called scalars. Scalars are numbers. Right? Scalars are numbers. Now, if you have a scalar and you have a vector, okay, the scalar times the vector, okay, here's a vector. 2 times it is a vector twice as long, same direction. Minus 1 times it is a vector in the opposite direction, same size. So if the scalar is positive, then A times V is a vector whose magnitude is the scalar times the magnitude of V in the same direction. If A is less than 0, then AV is a vector whose magnitude is the absolute value, because it'd be positive, times the magnitude of vector V, but in the opposite direction. And if magnitude is the scalar 0, then it's the 0 vector. Right? That's what you have. But vectors, you need to be able to work with and talk about doing things with vectors. Right? So for example, here is vector V, vector W, and vector U. So V minus W, right? So one way to do that is to do V and the opposite of W, or put V and W at the same initial point, and here is the result. 2V, so 2V, 3W, put them at the same, there is the sum. Properties, magnitude. This is the symbol for size of a vector. So if you have a vector V, you put these 2 little lines beside it, you're asking for how big is it? What is its magnitude? What is its norm? And this magnitude always has to be positive or 0. 2 vectors that are in opposite direction are the same size, so their magnitudes are the same. And a scalar times a vector is the same as the size of the scalar times the vector. vector u is called a unit vector. We use this term if the size of the vector is 1. It's called a unit vector. Now, this is geometrically using lines and vectors and starting points and ending points. But we can also do it geometrically in what we call the component form. The component form. And the component form is an ordered pair. Notice we use little pointed guys so that we can see that they is a vector. Okay? It's called the component form of the vector. So if you have a vector in component form in standard form, the position vector means the initial point is the origin, goes to some point P, and the vector and the end point are equivalent because this is 0, 0. So A minus 0 and B minus 0 is going to give you AB, and there's the component form. But in general, if you have 2 points, an initial point and a terminal point, then the vector V is the difference between the terminal point minus the initial point. To subtract ordered pairs, you subtract the components. So x2 minus x1, y2 minus y1 gives me the vector. Vectors. Right? So here's a ordered pair, minus 1, 2, left and up, and 4, 6, right and up. There's the vector. And what vector is that? Well, it's terminal point minus initial point. 4 minus a minus 1, 6 minus 2, which gives me 5, 4. So I put that in standard form in position. I start at the origin, and I go 5 to the right, 4 up, and this vector. These two vectors are equal, same size, and they point in the same direction. Those two vectors are equal because they're the same size, and they point in the same direction. So two vectors are equal when it's in component form if their first components are equal and their second components are equal. Another way, third way, drawing them, writing them in ordered pairs, or using what we call these unit vectors, special unit vector, the vector 1, 0, meaning to go 1 to the right, don't go up or down. That vector is 1 unit long. And the vector 0, 1, go right, left, 0, and up 1. This is related back to the unit circle in the very first chapter, very first thing we talked about. And so we could write a vector in component form, A, B, or in linear combination form, A times 1, 0, which is A times I, and B times 0, 1, B times J. And this is called the combination, linear combination form, where we have a horizontal and a vertical component. And so adding and subtracting, pretty easy with both of these forms. If you have two vectors and you want to add them, add the first components, add the second components, or the first component's I, the sum of the second component's J. Subtraction, the norm, and here's an important piece, a norm of a vector in either component form, AB, or in linear combination form, AI plus BJ, is the square root of the first component squared plus the second component squared. That is called our component form of a vector. And you should be able to do some problems and do some work with those. And you can look at these examples, and I'll do a pin cast on them to make sure you can do that. Very important piece. If you have any vector, there is a unit vector associated with that vector that's in the same direction. That is in the same direction. It's called the component form, or it's called the unit vector. So any vector has associated with it a unit vector in the same direction. Any vector has a unit vector associated with it in the same direction. And so any vector can be also written as the size of the vector times the unit vector in the same direction. Size of the vector, unit vector in the same direction. We could also use, as a unit vector, cosine alpha I plus sine alpha j. Back to the first chapter. Remember unit circle? Cosine squared plus sine squared is 1. So any vector in that unit circle is 1 unit long. And so if you want to write a vector, if you know the angle, that becomes its direction, and its size will be the size of the vector, cosine of the angle I plus sine of the angle j. Unit vectors. Used a lot in physics and problems like that, but that's the information on the vector. I'll do some pencasts on several of the problems, and you can look at that. But there's the basis of vectors. Spend some time looking at the problems and working on them.